Hi guys, today we'll talk about sliding window median. Let's go to the problem statement. They're talking about that they want to find, this is what they're talking about, the median. That median is a middle value in an ordered integer list. If the number of elements are odd, then the middle element would be the median. If the number of elements will be even, middle two elements divided by 2 would be the median. Now, there is a little twist, little tweak in this question with finding median. So let's go further. They're saying, given an array nums, there is a sliding window of size k, which is moving from the very left of the array to the very right. You can only see the k numbers in the window. Each time the sliding window moves right by one position, your job is to output the median array for each window in the original array. So let's go and understand with an example. All right, so let's start with the flow that will follow. Again, we will go with Reacto. We will either read or we will repeat. We will read if there will be some textual statement. We will repeat if orally that question was being asked. We will go with some example, and then we will, by going through this, we analyze and we try to map what we already know, and then we will come to our approach at how we can solve this question. Then we will go to the part of coding, and then we can apply some test. We can use whatever input we used, we can just apply to our solution. And for all, we can try to optimize, but most of the cases we will try to go with a better approach. Well, this is the flow that we will follow. Before solving this question, I can go and summarize what we already know. From here, I will connect that our knowledge that from one state to another, and then from there, how we can apply the coding pattern in solving different type of questions. Well, at the very start, we talk about some coding pattern. In those coding pattern, we first talk about two heap coding pattern. In two heap coding pattern, we talk about there are two rules. There are two rules. The first rule that if we have anything in order and we want to find something in middle of that, so that in this case we can apply two heap coding pattern. In this case, we go and apply and take max heap and min heap. We put elements in both of them, and then we solve the question. Second rule we talk about, it is like where if some object contains two property p1 and p2, the p1 is directly proportional to p2, and in requirement it was expected that they want such a state where p1, we want maximum p1 at the point where p2 is minimum. So we never talk about this question yet, for sure. In next question, in all subsequent question, we will talk about this. But currently we are focusing, we will focus on this type of question. Now let's talk about what we did after that. First, we completed our coding pattern. The next stage we talk about, we solved in our previous video, we talk about find median from data stream. So what was that? The requirement was about that we will get some data stream, and we have to design find median solution. And in this, what we implemented first. What is median? Again, I'm just summarizing all that. Median is we have a sequence of number, and if it is even, like 1, 2, 3, and 4, then 2 plus 3 by 2 is median. If it is odd, like 1, 2, 3, so this is median. In find median from data stream, we came up with a solution that we talk about that, okay, this type of solution by using two heap coding pattern, we first get, like for the previous solution, we talk about that we will make a max heap, we will use a min heap, okay, max heap, and we will use a min heap, and then we design some, we define some function, like we talk about def add, where we keep on adding some number, and we keep on adding. How we add, actually, we implemented two function. First is add, second we normalize, or we can say rebalance heap, or so normalize, let's suppose. We implemented these two functions, and then in second part where it was said we had to find median, it was very simple. We just go and we just saw that if it is even, in case it is even, then for max heap dot head plus min heap dot head, both of that we divided by 2, and in else part we said max heap dot head will be our median. So that was a solution what we implemented. Now, considering these all things, like two heap and all that solution where we implemented add, find median, we have to come to this question now. Up to here we have revised what we know. So I just summarize, revise what we know. Now in the next part we will talk about the example, and from example I will try to map what we already know and then how we can solve this new question. Now we'll pick a very simple example that will try to cover all the use cases. So we have to go in mostly picking very simple examples. So let's suppose we go with 1 minus 3, 3 minus 1, and 5. In this question they were saying to find median with some sliding window size. So we can, so in this case, if I will go I draw a table, let's suppose I consider that this is a simple table. I consider that window size is 3, and they want to find a median of that window size. So I consider that this, if I go in this way, for visibility I am just making this matrix here. So what they were talking about, they're saying that we need a window size of 3, and for this window size we want to find the median. So what they're talking about, so we say that this is the size of a window, and from this window we find these 3 numbers, and first we have to consider that they should be minus 3, then it should be 1, and that should be 3, because they should be in order, like from min to max or max to min. So that part, this is actually the median. So they were expecting that should be the answer 1. So this is the answer, what they're expecting. So 1, and when we slide the window, we left one part from here, we left it, and we picked the next one. So the next window will be from here to there. So we are going to include this new number, and we are going to exclude the previous one. From this window size they were talking that what will be the median. So if we see, so we can order that to find the median. So minus 3, minus 1, and 3. So this is minus 1 is a median for the second window size. Now we slide that window again, we skip one number from here, we skip that, and we include the next number. So that will be the window of size 3. We reorder that, so that will be minus 1, 3, and 5, and that would be median 3. So the answer for the given question should be 1 minus 3 minus 1 and 3. Now when we go through this example, we try to find that what we already know, and from there we try to find the solution for this new question. What we already know, let's suppose that window size is exactly the size of the data stream or the data set we have. If this window size is exactly 3 and we have 3 number of digits, we already know how to find the median. Okay, so we can apply something similar for this part. So we can divide our solution into small sizes, and if we know some solution that can solve the very small part of the question, for sure we can try to solve the bigger problem. So we know already that to find median, we can apply two heap coding patterns. So two heap, so let me go back here. So to find the median, we can go and apply two heap coding pattern. And in this case of sliding window, what we see, we can just consider, I'll keep it like this. So we can see that if we go with for from, let's suppose, from size 1 to n, from complete size of that, and we will again call the same function add, that what we were using in previous. We can use, for sure there will be max heap, and there will be a min heap. And in this for loop, what we are going to do again, we will just add, we will normalize, or we will rebalance, I can say rebalance our heap. These two functions are absolutely fine. In this case, what should be the next? In sliding window, when we are going to slide that, we have to remove some number, and we have to add some number, rather than again adding all that numbers into some window. Why not we exclude what is at the end and we add what is coming next, and then we can again go and add and rebalance and then find the median. So here we talk about some condition, might be we are going to some condition that is going to say something that we have already found, like this is the window size, we have reached that, and now we are going to move for the next one to add the next number, and going to remove what was before. We have to remove that. So in this case we are going to use this window size, so maybe there will be some condition, so we can use some condition here to find where we are right now, and then when we will move for this, we can find our median. Now in this case that looks very simple, that what we are doing, this is the same function that we already know. We already know about finding median, we already know about this add function, rebalance, and we just have to consider this if condition, and that would be something very new. And also when there might be some other function that is going to adjust. So we can say there was one function rebalance, and there will be some function might be adjust that we can use to solve this question. Now that's the whole idea. This is what I was talking about, that if we know already something, and then with some little tweak we can find the solution for the next question. So we already know how we can find the median. We use two heap coding pattern, and if we already know about that part where we have given the solution for add and rebalance, and with little tweak with sliding window, we have to find maybe some new one or two function, and we can complete that solution. Let's see how we can apply that. Now we will talk about our approach. Now let's try to implement this, like how we apply this example, and let's see what we will do. We will apply our function, that how we are going to do that, and with some condition we'll see what that adjust function or remove number might be. We can implement here remove number, let's suppose, and let's see that how we can implement. So first thing, we know that we have to go with some two heap coding pattern, and there are a few things we already know. so I don't go with that. We already know about add. I will just show that how we are going to add visually. We already know about rebalance or normalize, so I will just visually explain. Then we will talk about this new function, remove num might be. We can talk about that. So let's see that how we can use this. So using this example and using to heap. So first we know that there will be max heap and there will be a min heap. Again, I explain, I just keep the convention. This is small, so it's a min heap. It's broader, so it's a max heap. So it's a max heap. This is a min heap. So this is max heap, this is min heap. We try to implement that. So we go with this for condition and we go from 1 to n. So first we will add it, whatever number it is, we add that number. In the first case we get 1. Okay, window size is, let's suppose k is a window size, which is 3. We add this number, we get 1. We add it here because max heap is empty, we get it here. Next we get -3. So first we will look at the top. This number this number 1 is bigger than -3, which is coming. So for sure this number will go into max heap. Well, we'll put it here, -3. Next we will get 3. It will come here. We'll see the first number, which is maximum, which is less than the coming number 3. So it will send in this add function, it will send 3 here. And when we were adding also, it was going to rebalance. Please go and check the function first. The previous video, find median. So from there, a half question was being explained how to do that. Now, when we come to this point where we have 3 numbers there, this if condition might be is going to talk about, it is looking for that, okay, window size reached. So in this case, this could be a Boolean implementation, that is function that returns Boolean value. Yeah, the window size is reached. In that case, we will go inside and we will first find median, and that function we already know that it is going to get the value median. In this case, he will find here you will see that he will find in max heap and min heap total number of elements are odd. So in case of odd, he will just look for max heap. In this case, he will just find the median. So we will get the value. So for this value, we will might be save in some list. Maybe we will save our answer in some list. So we will add 1 in our answer. We have to slide the window. We are going to move the window for the next section. So we have to remove some number, which is this one, and we have to add the next number, which is that. So how we will do that? So let's see. We just visually look how we are going to do that. So the next number is coming, which is -1. So we were expecting to delete 1. So visually how it will happen. So we will get -1. So -1 is less than, first we are going to add it. So -1 is less than this number 1, which is the top element of max heap. So this -1 will go into the max heap. So we will get it here. Remember that this is not actually how it looks like a max heap and min heap. It's a balanced tree, so it is not like that. So I just visually explain that how it is. So -1 will go here. He is going to rebalance from this function. So he will say rebalance because max heap contains more than 1 element. The difference is more than 1. So he has to shift some number there. So 1 will be moved to our min heap. So the state will become like this when it will rebalance. After rebalance, he is going to say -3 and -1, and min heap will contain 1 and 3. Now the step will come for removing. We want to remove it. To remove this element, which is this one. This is the number that we have to remove because we add -1 and we want to remove 1. So when we have to remove 1, in this case, we have to find it. So when we will try to find 1 in this number, so first we will look at the top of this max heap greater than the number that we want to delete. It looks like that it should be here. It should be in the max heap for sure. Because we have already added the number in an ordered way, so it should be here. So here we have to remove this number. But if the max heap top number, this is wrong actually, that should be -1 and that should be -3. So if the number is at the top of the max heap is less than to the number that we want to remove, so we have to go and see into the min heap. So from the min heap we want to remove that. There is some logic for removing. So to remove some number, we have to see either we have to remove it from either remove from max heap or from min heap. So either of that. So first thing what we were talking about, the rule might be that will become some condition that either we have to remove it from max heap or min heap. So first we think about that this is the maximum number that looks like an umbrella, and all the numbers that will be less than this, which might be we were trying to delete. Let's suppose if we have to delete -3, we have to remove that. So we come here, we see the top number of max heap, so for sure -3 will be here. So we will go and try to remove from -3. But if it is not the case, so we will go to the min heap and we will remove from there. The next thing, how we will remove that, how to remove. In how to remove, what I think in a very simple way, this number could be here, it could be here, it could be any place. What we can do, we will let's suppose make a temporary some list, and let's suppose we were going to remove from max heap. So if we are going to remove from max heap, in this case we will put all the elements from max heap to some temporary list where we will find the number. We found the number. What we will do, we will remove it, and then from this list we will add all the numbers back to max heap. So what I was talking about, I'm saying find that number. So to find that number, what I'm saying, from max heap we will keep on adding number into our temporary list. When we found it, in this case we would delete it, and then we would go back and return. We will from list, all elements we will send back and add it into the max heap. That would be the flow. This is how I was looking at. The whole picture looks very familiar. I just go with the block concept, how we can solve this question. Pretty simple. That will be, we will iterate, and we will add all numbers. We will rebalance for adding each number. So we are going to add, we are going to rebalance. We will get some condition which will see that if we have reached the window size, so there will be some condition, and here we would find our median that we will add into our answer. So that will be another function, and here we will remove number. That will be some other function that we are going to call. This is the whole solution. That's it. There is no other thing. This is a solution. That's it. When we try to get some answer in such a way with some function, so you can write this solution, and then one by one we can go and solve, and we can provide the implementation of each function. In that case, we can save the time and we can give the whole picture that how we are going to use it. Though let's see and how we can solve by using the code. Welcome back. So let's try to implement the code. Okay, so we have already come to know that we are going to use two heap coding pattern, and for this we are going to define max heap. Max heap will be our priority queue that should take int, and ordering will be natural int ordering, and for min heap we will go and define a priority queue, which will take int, and ordering should be of int dot reverse. We can go and import scala dot collection dot mutable all. Okay, and we also define that, okay, let's go and get your answer. Might be, it would be better, so we can go and say list buffer, which will take int, and we define it here. Now we come across our block functional diagram, or the function that we were trying to do. So first what we will do, we will go and we iterate on all the numbers that we are going to get. In arrays, we can use, I think the better way, we can say num and index, or I can say k maybe. So we are going to say nums.zip with index. So what is zip with index in Scala actually? So in arrays, we already know that on index, let's suppose if I talk about the same example that we were talking about, 1 minus 3, 3 minus 1, and 5. So from here we come to know that at 1 is at index 0. Is at index 0. Minus 3 is at index 1. And 3 is at index 2, and so on. So zip means it goes from here and zip, make a zip and make this num. It returns actually from when we zip it, it returns us a tuple of 1 and 0. So this is just for sake of explanation with Scala. Okay, so num zip with index, and we get both of them as a tuple. We will do the same. We are going to add, this is the function that we already talked about in find median from a data stream. And the second function, we just give it the name of normalize. Here we can say rebalance with these two heaps, and here we are going to add num. All right, so this is pretty simple. Yeah, we will implement this function. Now for that condition, how we can come to know that we have reached our window size, because when we reach the window size, this is the time that we have to find the median. So we can say, here we can say that k might, so window size is in k, so we can give this index name might be right. That will be the right index where the right of our window is going, so that will be the number, that will be the index. So we can say right minus k, we subtract the size of window plus 1, because index start from 0. So plus 1 if it is greater than equal to 0. So we have our window. If we have our window, we can find median. This is what we talk about. And for adding answer, what we can do in find median, we will just write a single line where we can add the median into our answer. Now in the next step, we have to remove number. Here we have to remove num. Which num? We have to get this number. Which number we are going to remove? Absolutely, the number which is going to remove is at the end of this window, sliding window. So we say num to remove. Let it make more explicit. So we say that number will be nums that we are going to remove is right minus k plus 1. That is the number we are going to remove. So if we are going one step ahead, that will be 0. So we are going to remove the number at 0 index. So that is the number we are going to remove. So num to remove. Well, we have written our whole solution. What about these functions? We already talked about add, rebalance, or normalize, and find median, all these three functions into our previous median for data stream. So I will just copy here and try to go to solve this remove number. Okay, so with the magic, I'm going to get all those functions here. Here we go. So I just explain them quickly. So I'm not going to type to waste the time. So we are saying that max heap is empty, or max heap number at the head is greater than or equal to num. So we will enqueue into max heap, else we will enqueue that number into min heap. In the rebalance, what we are saying, we are saying that if there is a difference of more than one, and like max heap is going to contain 3 numbers and min heap contains 1 number, we have to balance. So we already saw in the explanation that we shift 1 from the top of max heap to min heap. So we have to shift that. So from max heap, we will dequeue and we will enqueue that into min heap. From in the else part, if max heap size is less than min heap size, we are going to dequeue from min heap, and that number will be enqueue in the max heap. Find median, pretty simple. We will get this if median dot size is equal to max heap size is equal to min heap size, so we will just take their both of head, because even number of elements are there, so we will get both of them, divide by 2 and get the median. Else, for sure, max heap top element is our median. What we are going to do next, we are going to say answer.add 1 median. This is the median we are going to add here. So that was what we were talking about, adding median into solution. So here we are adding that to solution, to our answer, better to say. Now we talk about this function that remove num. Now let's implement remove num function. So we say def remove num. We were expecting some number that we want to remove. This function is not going to return anything. Okay, what we will do, we'll say val. We will maintain a temp list buffer that is gonna to keep all the numbers that doesn't match with the number that we are going to remove. Okay, so what we will do, we will say if max heap dot head is greater than or equal to current num, and that max heap dot filter, let's suppose with the current one, with the current number dot size is greater than 0. If this max heap contains this number, then we can go and remove from max heap. So we will make some might be function that is going to remove this number from max heap, but this is the condition that we are going to check. Either this is what we were talking about, that either we have to remove from max heap or we have to remove from the min heap. In the else part, we say remove from min heap. Now we write this local function. We say remove, and it is going to expect some heap that will be a priority queue, which is be of type int, and this function is not going to return anything. This body will say okay. So what we are going to do here, we say while heap, either it is a min heap, either it is a max heap, it is non-empty, and that heap dot I will say heap dot head is not equal to num. If it is not equal to number, then go inside and in the temp add 1. So heap dot dequeue, we keep on dequeuing and adding into the temporary list. Once we found it, yes, we found that number which we want to delete from the respective heap, we go out and we say heap.dequeue. So we remove that number which we want to remove. So we remove it, and now we will say from that temp, for each whatever we have saved, put this back in the max heap. So that heap, either max or min, we enqueue back into our heap. That's it. So this function is simply doing that. We check here that either we have to remove it from max heap or min heap, and then this function is going to extract those numbers, because there is a chance that number that we want to remove is not at the top. It might be under some level, on some different level of that max or min heap. So we have to iterate. So on all top elements, we were going to first remove that. We are going to put them in a temporary list, and then once we found it, we go and remove that number from the heap, and then we put back all those numbers what we have extracted from the max heap. And that's it. And at the end, we can just say that answer.toArray, because this is a list, we want to return array back. We run it, and yes, that's it. So thanks. Hopefully that makes sense. Thank you.